In the next series of videos, we are going to be looking at concepts in stoichiometry. Now, we are going to first start by looking at the physical quantities and the SI units, of which the mole is one of them. So the big idea here is that the mole is the SI unit for amount of substance N that is used to help chemists count elementary particles that make up substances and provides a means to connect the macroscopic views of matter, such as mass and the volume of gases, to the microscopic view and the number of elementary particles. So the next few videos are going to focus on the mole as the SI unit for amount of substance. And it's going to be placed in the context of the other fundamental quantities that we measure. So what's important to know is that 1 mole of a substance is equal to Avogadro's number of particles. Hi, this is the Opinionated Science Educator. Welcome back to my second video on the mystery file related to the mole as one of the SI units of the 7 fundamental quantities. The mole is the SI unit for amount of substance. So let's start by recapping what the SI system of units are. There are the 7 fundamental units. Mass is in kilograms, length is meters. Time, the SI unit, is the second. Then there is current with the SI unit of the amp. Temperature's SI unit is the Kelvin, and the amount of substance is the mole. Luminous intensity is candelera. So there are the 7 fundamental quantities that we measure with their SI units. Okay, so in my investigation, I looked at some of my chemistry textbooks. Now, the latest ones define the mole as the SI unit for amount of substance, and that 1 mole contains exactly 6.02 times 10 to the 23 elementary entities. And this number is fixed and is called Avogadro's number. So the amount of substance with symbol N of a system measures the number of specified elementary particles, and those can be anything. But then I also found in older textbooks that the definition of the mole is 1 mole is the amount of any substance that contains the same number of particles as the number of atoms in exactly 12 grams of carbon. So 12 grams of carbon is 1 mole of carbon, and in 1 mole of carbon there are 6.022 times 10 to the 23 carbon atoms. But that is an outdated definition. Now, interestingly, I also found that in chemistry, yes, the mole is the SI unit to measure amount of substance, but in Latin, mole means a massive heap of material. So it would be convenient to think of the mole as a heap or a pile of materials. But there's a pile of sulfur, a pile of carbon, and a pile of sodium chloride. So exactly what is in that pile? Well, that's what Avogadro's number tells us, or the definition of the mole, that there must be 6.022 times 10 to the 23 particles in that pile. Now, that 6.022 times 10 to the 23 is a very big number. So in my investigation, I found this interesting video, animated video, that I'd like you to watch that gives you some ideas as to just how big a mole is.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your aunt's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you have equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amadeo Carlo Avogadro. Wonder how long it took him to sign autographs. Unfortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particles. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind, Avogadro was the first one to come up with this idea, scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number. Now, back to the mole. Not that mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or a 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. So there you have it, the story of the mole, Avogadro.